My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 196. In this lecture, I will continue my discussion on logistic regression. Now we will try to understand how one can calculate chi-square value from G statistics. I already discussed about G statistic in my previous lecture, that is in lecture number 196. Just see this one. This is screenshot of your Jupyter notebook. At the end of this lecture, we will try to understand these things in Jupyter notebook. From SciPy, this particular library, we discussed about this library in previous lectures. From SciPy.stats, import chi-square. Yes, now we are importing chi-square. This is chi-square.pdf. We know what is PDF. PDF means what? Probability density function. Means it will give, basically it will give probability. Just probability. Just try to recall our previous lectures on PDF so that you can understand what is probability density function. Basically what it gives probability. Just say 13.628. It will take first argument as G value. This is G statistics. I already discussed about this, how one can calculate G statistics. We discussed in previous lecture. This is degrees of freedom. How will you get degrees of freedom? Degrees of freedom in logistic regression. Degrees of freedom is number of independent variable. Here card is number of independent variable, that is Siemens credit card, and another number of independent variables, another one is spending amount, isn't it? There are two independent variables, there is 2 degrees of freedom. If you calculate this is the probability, isn't it? If you observe carefully, this output p value is very low, means this probability value is very low. Even I can say it is less than 0.05, isn't it? We can say the model, as a model is, we can say model is significant. Model as p value is very less, I can say model itself is significant. In similar manner, Z test can be used to determine whether each of the individual independent variables is making significant contribution to overall the model. Just Z test, there is another name for Z test is Wald test, isn't it? What it says, Z test can be used to determine whether each of the individual independent variables is making significant contribution to the overall model. What is the formula for Z test or Wald test? This one is already we discussed. Just this is summary of our logistic regression which we discussed in previous lectures. How can I calculate this one? Coefficient. This is coefficient by this, I can say this is coefficient. This I already discussed in previous lectures. This is by standard error. That is standard error. That is Z statistic, or I can say it is Wald test. How will you say what is your for card? If you consider card, what is coefficient? What is beta 1 cap? That is 1.0987, isn't it? What is your corresponding error? I can say 0.447. That is essentially you will get 2.4707. This one. This is your Z statistic. In similar manner, what is your beta 1? That is coefficient for spending. This is for what? This is for card. Card is one independent individual variable. Another independent individual variable is spending, whose coefficient is 0.3416 by its corresponding standard error. This is your coefficient. This is your standard error, 0.1287. You will get, what is its value? 2 points. What will you get? 2.6551 you will get, isn't it? Corresponding probability. This is known as Z values. Even you can see the corresponding probabilities. What is for card? For card, what is the corresponding probability? 0, let me write, chord is one independent variable whose probability is 0.0135, isn't it? Another independent variable is spending whose probability, let me write, this is spending whose probability is 0.0079, isn't it? Both probabilities are less than 0.5, isn't it? This is less than 0.05 and even this is less than 0.05, isn't it? Both the probabilities are less than 0.05. So we can say both the independent variables are significant. Therefore, these two independent variables are, these two are significant, isn't it? Significant. I can say you can reject null hypothesis. As a whole, model also significant. Independent variables are also significant. Once we know both are significant, then we can go for interpretation of this output. So what kind of different strategies that company has to adopt? We will try to understand strategies so that I will repeat. So what kind of strategies that company adopt so that they can improve their revenue by selling more coupons. Suppose Siemens wants to send, let me say like this, suppose Siemens wants to send the promotional catalog only to customers who have 0.40 or higher probability. Here you must understand what is their strategy. They suppose Siemens wants to send the promotion catalog only to customers who have a probability of 0.40 or higher probability of using coupon. So what will happen? Just observe carefully. Customers who have Siemens credit card sending the catalog to every customer who spends $2,000 or more last year, isn't it? What does it mean? Jesse, $2,000 or more. $2,000 or more means what? What is your $2,000 means what? Just see this one. This is 2,000. What is strategy? More than 0.40, isn't it? This, observe this, all the probabilities are their probabilities is greater than what? Greater than 0.40. Therefore, you can send catalogs to every customer who spent $2,000 or more last year with credit card. That's important. With credit card. Just see, customers who do not have Siemens card, this is those customers who have Siemens credit card and whose spending amount is more than $2,000. All the probabilities are greater than 0.40. Therefore, you can send your coupons to all these customers. Customers who do not have Siemens credit card, send the catalog to every customer who spent $6,000 or more. Just see, no credit card means this is no credit card. No credit card means greater than 0.40 means only these two entries. This one is greater than 0.40 probability. Therefore, I can say those customers whose spending amount is 6,000 or more than 6,000 and who don't have credit card. For those customers also, you can send coupon. Isn't it? This is the basic strategy. In next lecture, I will discuss about interpreting the logistic regression using the odds ratio. What is that odds ratio? That things I will discuss in next lecture. Before concluding this lecture, what will I do? Just let me go to my Jupyter notebook and we will try to understand this simple code in Jupyter notebook. These are the, we already discussed many times about this particular libraries. Let me proceed. This one is Siemens.xls. This one is a file in which we store data. That is Siemens.xls. That one we are creating a data frame. Let me print that data frame. As I told you, this data frame consists of 100. Just see, there are 100 rows and 4 columns. Just see, there are 100 rows and 4 columns. What is this? this coupon is dependent variable. Spending and card are independent variables. There are 100 customers. This is the data set which we did, but in our PowerPoint presentations, for convenience, we have shown only how many we have shown 10 customer details. Here customer number 0 to 99 means there are 100 customers details. Now what am I doing? This also we discussed in PowerPoint slide. Scatter plot. How can I plot scatter plot? In between spending and just say this scatter plot, how we plotted in between spending is on x-axis and coupon on y-axis, marker equal to plus, color equal to red. Therefore you are getting this will lead to a S-shaped curve. You cannot fit linear regression for this particular output. If you want, I will minimize and I will show you this. Just you cannot fit linear regression. You must, as it is a shaped curve. Now let me say, now I am taking on x-axis, I am taking what am I taking? Card and spending. That is I can say they are independent variables, and coupon on y-axis, y equal to coupon and x equal to card and spending. If I take x and y, and what I have to do, just this logistic regression also I discussed what it says. Just see, this is import stats model. The add underscore constant I already explained in previous lectures. Logit also I explained. Logit model fit summary too. All these things I explained. This is the output. This is summary output. Let me reduce the screen size so that it may be clearly visible. Just see, this is number of iterations 6, and the model is Logit. Dependent variable is coupon. Number of observations 100. DF model means degrees of freedom of the model. How will you get? Number of independent variables. How many independent variables? We have card and spending. These are 2 independent variables. And log likelihood I already explained. LL null value I already explained. This p value, LLR p value we discussed, and we also discussed what is Z value. How can I calculate Z value from coefficient and standard error? In this lecture only I discussed about these probabilities value 0.0135, 0.0079, and from this one even we can calculate. You can calculate chi-square value. How can I calculate chi-square value? One can calculate chi-square value by using G statistics and degrees of freedom, isn't it? Just see this one. What it says, this is simple and straightforward. Chi-square.pdf. PDF means probability density function. This 13.628 is my G value. This 2 is independent, number of independent variables. Just see what you are getting, 0.0054. This is very low. This probability value is very low. Therefore, model itself is significant. Even depending on card probability value, this is 0.0135. It is also less, and spending probability value is also very less. Therefore, this independent individual variables are also significant. Overall model is also significant. This lecture is simple and straightforward. Just go through this lecture, and if you have any difficulty, just keep a comment so that we will try to understand. In my next lecture, in lecture number 197, we will try to understand logistic regression equation with respect to odds ratio. Thank you very much.